mathematical formulas which we did. And we had to start the new chapter.
Okay, that's chapter number 3. We have completed that mathematical portion of about integration.
Yes, sir.
Okay.
Sir, I had also submitted the assignment on the app.
Okay. So let's start the new chapter. First is, what do you mean by mechanics? So mechanics is the oldest branch of physics, which mainly deals with two terms: study of body at rest or motion. So we may divide these two terms, rest or motion. So study of a body at rest is termed as statics, and study of object in motion is termed as dynamics. So you'll say statics means if a body is experiencing a number of forces and due to which net effect would cancel out, as a whole object would be in equilibrium or at rest, then the study of all interaction is termed as statics. Next is dynamics or motion. We may divide this particular term into two parts. Let's say if you have a body having mass m, and if a force is applied on it, force, work done, energy, on the application of this particular force, object will move along this path by some amount. So it will have displacement, distance, speed, velocity, acceleration. So it will have distance, displacement, speed, velocity. From this, you will say these terms are nothing but the consequences or result of that particular motion. But these terms are nothing but the cause of that particular motion, like force, linear momentum, work, and so on. That's why we divide this dynamics into two parts. First is called kinematics, and second is called proper dynamics. In kinematics, we mainly define consequences of motion, which means distance, speed, displacement, velocity, acceleration, and so on. Next is proper dynamics, or you can call it as causes of motion, like force, work, energy, linear momentum, and so on. Is it clear till this part?
Yes, sir.
Shab, any doubt? Just write it down.
Done, sir.
Done, sir.
So the first part is kinematics. Kinematics derived from a Latin word which is called kinema. Or you may call it as cinema, which means motion. So as a whole, you will define this kinematics as the branch of physics which deals with the study of motion of body or study of result of motion of body without considering its causes is called kinematics. So it is nothing but study of consequences or result of motion of a body without considering its cause is called kinematics. Now we may further divide this particular kinematics into two parts. First is called uniform motion, and second is called non-uniform motion. I think you all learned about these two terms in class 9. Uniform motion is nothing but if a body covers equal distances in equal time gap, then acceleration would be 0. That is called uniform motion. So in this part, I will define you distance, displacement, speed, average speed, velocity, average velocity, only these terms. Next is non-uniform motion. It means acceleration is non-zero or it will have some value. So on the basis of this term, we may divide into two parts, whether it will have a constant numerical value or it will have some changeable values. So it will be termed as uniformly accelerated motion. And next is called non-uniformly accelerated motion. It means for uniformly accelerated motion, the numerical value or the acceleration would have constant numerical value. Let it be 2, 5, 1, or it will have some variable value, either time dependent or position dependent function. So we may divide this non-uniform motion on the basis of its value, whether it would be constant, so we can call it as uniformly accelerated motion, whether its numerical value would changeable, so we can call it as non-uniformly acceleration motion. Now this uniform accelerated motion may be further divided into two parts on the basis of considering a long horizontal line or a long vertical line. So for vertical line, it will be termed as free fall or motion under gravity. Is it clear till this part? Namuna, any doubt?
No, sir.
Shoaib, any doubt?
No, sir.
So we mainly have four different sections of this particular chapter. First is this. Second is uniformly accelerated motion along horizontal line. Third is uniformly accelerated motion along vertical line, or you can call it as free fall or motion gravity. And next is non-uniformly accelerated motion, for which velocity, displacement, acceleration, these all would be time dependent, position dependent function. Just write it down.
Done, sir.
Done, sir.
So first topic is uniform. So you will say if body covers full distance, full time gap, that is called uniform motion, in which the first term is what do you mean by distance and displacement? Namuna, just tell me about these two terms.
Distance, it is always positive,
Okay,
and it's a scalar quantity.
okay,
And displacement,
basically all of the scalar term would be positive always.
yes, sir.
All scalar term would be positive always.
Yes, sir.
Shoaib, would you like to explain these two different words? Okay, let me define you. Suppose this is your surface and there is insect at this point and is allowed to move along any direction. So it will move like this to reach at this point. So this will be your initial term or initial point, and this is final point. So distance is nothing but the actual path covered by any object while going from one point to another in any direction randomly. So it is termed as distance. So you can call the actual path covered by a body is called distance. But for displacement, there should be shortest path in between initial and final point. So let's say this is your initial point and this is your final point. So if you join these 2 points, it will be like this. So you will say the shortest path between initial and final point. Is it clear, Amuna?
Yes, sir.
Okay. Now the next term is while going along actual path, first from A, it will be along this direction, this, and so on. It means there is no fixed direction on going along actual path. So you'll say there is no fixed direction. But in displacement, for shortest path on going from initial to final, there should be some fixed direction. So it will be fixed direction. Since both are length or path length, so it will be measured in terms of unit, that is meter. So it will be meter. Now I'm defining you relation between these two different words or quantity. Relation between distance and displacement. First, let's say for a straight path from this point to this point. And second, for any semicircular or curved path like this. A to B. Since path is straight, so distance will be AB, and similarly displacement will also be AB. So you'll say both distance and displacement are equal for a straight path. Next, for any curved path or semicircular segment like this, this is your starting point and this is your final point. On going along this path, which is nothing but half of perimeter of the circle, so distance is equals to pi times r. But for displacement, which would be shortest path between initial and final point, so it will be this, which is nothing but diameter of the circle. So it will be radius, and radius, it means 2 times of r. Now, if you compare these two terms, distance is pi times r, pi having value as 3.14, and distance displacement is nothing but 2 times of r. So pi is greater than 2. So you'll say distance is greater than displacement. So distance is greater than displacement. Now, if you combine these two different words, you will get distance either greater than or equal to displacement. Now, if you want to take the ratio of these two terms, you will get distance divided by displacement greater than equal to 1. Is it clear?
Yes, sir.
Shab, do you have any doubt till this part?
No, sir.
Done, sir.
Done, sir.
I'm giving you one problem on the basis of this. Try to simplify. Man goes 8 meter, then 4 meter north, then 2 meter west, and then 1 meter south. Find distance and displacement from origin. First, try to figure it out and then apply the concept to get distance and displacement both. Should I give you some clue? Namana?
No, sir, I'm fine. So for finding the distance, since it's given that 8 meter east, 4 meter north, and west 2 meter, and 1 meter south, so we can just add all of them. We'll get it
Yeah,
like that. Then
this is
displacement.
nothing but a scalar quantity. So it won't depend upon direction. So you have to take
Okay,
the sum of all.
and displacement we can do 15 divided by 2.
Why divided by 2?
If it would be only two distances mentioned, then it would be easy. Like if 8 and 4 is mentioned, I can subtract and get displacement. That will be the shortest distance. But since here 4 are
But
given,
but these two are not in just opposite direction. They are perpendicular to each other. First is going along east and second is going along north. So how do you subtract it to get the displacement? I've told you, you have to figure out this particular term according to this east, west, north, south. Let me give you some clue. First, 8 meter along east. So it will be like this. Next is 4 meter towards north. So it will be like this. Next is 2 meter towards west. So it will be like this. And last, 1 meter towards south. So it will be like this. Is it clear, Maimuna?
yes, sir.
Now for displacement, which is nothing but the shortest path between initial and final point. So just join initial point, that is this part, and final point, that is this part. Let's say A, B, C, and D. So to get displacement, just join these 2 points. So how to get this particular value? I'll just draw perpendicular to it like this. Now we have 8 meter along east from O to A and 2 meter west from B to C. So on subtracting, you will get this part. Is it clear, Shreya?
Yes, sir.
Similarly, 4 meter towards north from A to B and 1 meter towards south from C to D. So if you subtract these two terms, you will get 3 meter from D to E. Now see, in this particular triangle, we have perpendicular and base both. To get displacement, which is nothing but hypotenuse of this triangle, just use Pythagoras theorem to get your answer. Okay, Mamuna?
Okay, sir.
Shoaib, solved. Distance is nothing but the actual path. So it will be 8 plus 4 plus 2 plus 1. So in total, it would be 15 meters. And displacement, according to this diagram, it will be root under base square plus perpendicular square. So it will be 36 plus 9 root under, or it will be 45 root under, or 3 root 5. Is it clear, Shram?
Yes, sir.
Okay. Now, the next part is to define speed is nothing but the rate at which a body covers distance, termed as speed. Say the rate at which distance is being covered by a body. So speed is equals to distance traveled over time taken. I'm giving you one more relation to define relationship between these three terms. Just draw a triangle, divide it further. So this is D, this is S, and this is T. Now, if you have to calculate any of these three terms, just cover it. Suppose for calculation of speed, just cover it, you'll get distance upon time. Similarly, if you have to calculate distance, which is nothing but product of these two terms, so it will be distance, speed into time. Now, suppose if you want to calculate time, just cover it, so you'll get distance divided by speed. Is it clear?
Yes, sir.
Now, the next term is its SI unit. Distance is nothing but measurement of time and measurement of length. So it's SI unit will be meter, and time is in term of seconds. So its SI unit will be meter per second. But there would be some other unit as well, kilometer per hour. So just multiply it by 5 by 18. It will convert into meter per second. Or if you have meter per second, just multiply it by 18 by 5. It will convert into kilometer per hour. Now we have to mainly define in this part about average speed. It is defined for a journey, let's say from this point to this point. A, B, C, and D. A journey having some different path length. Let's say x1, x2, x3, and time taken is t1, t2, and t3, on the basis of which speed is v1, v2, and v3 respectively. I've just defined a journey ongoing from A to D having three different intervals AB, BC, CD, which having distance time and speed as x1, t1, v1, and so on. Now, average speed is nothing but ratio of total distance traveled by the body for the whole journey divided by total time taken. So it is nothing but the ratio of total distance covered by body in total time taken. So S average is equals to total distance traveled divided by total time taken. Total distance is x1 plus x2 and so on to xn if it contain an interval divided by time taken t1 plus t2 and so on to tn if the journey would have a number of intervals. Is it clear till this part? Sure.
Yes, sir.
Sure. Any doubts?
Yes, sir. Yes, sir. Clear.
Okay, just write it down.
Done, sir.
Sure, have you done?
Yes, sir. Done.
Okay. Now I'm defining you some special condition of this formula. First, if time gap are equal, it means T1 is equals to T2 is equals to Tn is equals to T. So distance is nothing but speed into time. So x1 is equals to v1 into t, x2 v2 into t, and so on to xn, which is equals to vn into n. Now put all these values in the previous part. So S average is equals to total distance, which is v1 into t, v2 into t, plus so on to vn into t, divided by t1 plus t2 plus so on to tn. Now if we take out t as common from numerator, it will be v1, v2, and so on to vn, divided by n times t. This t and this t would cancel out. So you get v1 plus v2 and so on to vn divided by number of terms n. And again, this is defining you nothing but the average value of all individual speed. So you may call it as arithmetic mean of all individual speeds. So from this you can conclude, if time gaps are equal for this particular entire journey for each interval, then average velocity or average speed is equals to nothing but arithmetic mean or simply mean of all individual velocity. Is it clear, Amuna?
Yes, sir.
Similarly, there is one more condition. If path length are equal, it means x1 is equals to x2 and so on to xn, which is equals to x. These are nothing but path length. So if you convert it like t, time is distance over speed, and so on to tm, which is distance by speed. Now, if you put this all term in the previous formula, you will get average speed is total distance, that is x plus x to x, divided by time taken, distance by speed, and so on to distance by speed. In numerator, we have x up to n times, so it will be n times of x. Divide by, if you take out x as common, you will get 1 by v1, 1 by v2, and so on to 1 by v. This x and this x will cancel out, so it will be n divided by v1, v2, and vn. This is nothing but harmonic mean of individual speed. So you will say harmonic mean of all individual speed. So in total, we have three different formula for calculation of average speed. First is, if there is no relation between distance and time or speed, so average speed is equals to total distance traveled by total time taken. But if there is first equal time gap, then average speed is equals to total or arithmetic mean of all individual speed. And second, if path lengths are equal, so average speed is equals to harmonic mean of all individual speeds. Shrab, do you have any doubt? Mamuna, any doubt till
No,
this
sir.
part? Okay, just write it down. Abdul Wahid.
Done, sir.
Done, sir.
Okay. Why? You may take screenshot. Now, on the basis of this, I'm giving you some problem. You have to analyze which formula would be applicable in this. First, a man goes to market at 6 meters per second and returns back to home along same path. Then find average speed. Try to solve.
Sir, here
Amana,
only speed is given and
uh,
there is no distance. At least if distance will be there, we could have found time then.
1 minute, just 1 minute, and return back to home at 3 meters per second. So in this problem, he's going home to market and then returning back from market to home. Is the distance along going from home to market and market to home are equal or not? Mamuna,
Yes, sir.
is the distance along both two different paths are equal or not?
Yes, it's equal.
So if distance, that is x1 is equals to x2, so which formula do you use? This third part. Here we have two intervals, so just use n is equals to 2. v1 is given and v2 is given. Just put all the values and you'll get your answer. Okay, Shab. Wahid, is it clear? Mamuna, should I solve?
1 second, sir. I'm just sorry.
Okay.
Sir, here in this question, what is the value of n?
N is number of interval.
So it will be
So
2.
first is N is number of interval. Here we have only 2 intervals. First, or from home to market, and then market to home. So just use N is equals to 2, V1 is equals to 6 meter per second, and V2 is equals to 3 meter per second. Okay?
Yes, sir. I'm on the last.
Okay. Shoaib, just send me your answer. Good, Mamuna. Since distance or path length are equal, so just use S average is equals to N divide by 1 by V1, 1 by V2, and so on to 1 by Vn. N is number of interval. Here we have only 2. V1 is 6 and V2 is 3. Now, if you simplify it, you will get 2 divided by 6 as LCM. So it will be 1 plus 2, which is 3 divided by 6. So it will be 1 upon 2. So 2 moved to numerator. So it will be 4 meter per second. Is it clear? Sure.
Yes, sir. Clear.
I'm giving you one more problem. A car travels at 12 meter per second and 6 meter per second for equal time. Find average speed. Try to solve. In this problem, we have equal time. Just use the formula accordingly. Mamuna, any doubt?
No, sir.
Shab? Bahid, any doubt? I've just defined you for equal time gap. Use this formula. V1, V2, V3, so on to Vn divided by N. We have V1 as 12 meter per second, V2 as 6 meter per second, and we have in total just 2 intervals. So put the value of N to be 2. V1 is 6, V1 is 12, and V2 is 6. Apply the formula. Good, Mamuna. Good share. Let me solve. Average speed is nothing but v1 plus v2 divided by 2 when time interval are equal. So it would be 12 plus 6 divided by 2, which is equals to 18 by 2, that is 9 meter per second. Is it clear, Vahid? Now the next term is velocity. As speed is depending upon distance, so velocity is nothing but rate of change of displacement. So you will say velocity is equals to displacement over time taken. As I have defined you, for displacement and distance, for a straight path, they are equal. So you'll say for a straight path, speed must be equal to velocity. So for straight path, as distance equals to displacement, so velocity must be equals to speed. And as like average velocity, there is one more term which is average velocity, which is nothing but a ratio of net displacement to the time taken. So you'll say the ratio of net displacement to the time taken. So V average is equals to net displacement over time taken. Is it clear till this part? There is no any special formula regarding average velocity. Mamuna, any doubt till this part?
Yes, sir.
Do you have any doubt till this part?
No, sir, not yet.
Okay, Shoaib. Okay, just write it down.
Done, sir.
Abdul Wahid, done. Now the next part is non-uniform motion. If a body covers unequal distances in equal time gap, if body covers unequal distances in equal time gap, is called non-uniform motion, which may be further divided into two parts, uniformly accelerated and non-uniformly accelerated. So first is called uniformly accelerated motion. So first is, what do you mean by acceleration? As like velocity, which is nothing but rate of change of displacement, acceleration is simply rate of change of velocity. Rate of change of velocity or speed, both. Now to define this uniformly accelerating motion, or to solve uniformly accelerating motion, mainly use equation of motion. Till this part, you may have learned just three different equations. First is V is equals to U plus AT. Second is S is equals to UT plus half AT squared. Third is V square U square plus 2 times of S. And last is S nth, which is equals to U plus A over 2 times 2n minus 1. Any doubt till this part to any one of you?
No, sir.
Shab, is it clear till this part?
Yes, sir.
I'm defining you how to use these equations for different problems. Let's say if you have a path like this, having interval 0, 1, 2, 3, and so on. So to define distance or displacement between any two consecutive time gap, let's say between 0 and 1, between 1 and 2, between 2 and 3, and so on. So between 0 and 1, it will be termed as first second. 1 and 2, second second. 2 and 3, third second, and so on. So this is nothing but distance traveled between consecutive time gap. So it will be termed as point of time or between consecutive time gap. So the last equation, that is S nth, is defined only for this last part. So you will use S nth in this section, where n defines you the interval or the time on which we have to solve. Rest of the above three equations, these three equations, defines you for the period from starting point to that given interval. Let's say you have to calculate from 0 second to 2 seconds. So it will define you a period of interval of time from starting of the journey till that given point. So it is defining you from starting till that point of time. So above three equation is valid or based on this part. Now I'm defining you some relationship. First, V and U are the velocity of body at initial point and final point. A is acceleration, which is always constant for the entire uniformly accelerating motion, and T is time. So you can call it as velocity time relation. Next is S is equals to ut plus half at square is termed as displacement time relation. Next is p square u square, which is velocity and s is displacement. So you will say velocity displacement relation. And last, SNth is nothing but distance or displacement traveled by body in nth second. Is it clear to you all till this part?
Yes, sir.
Shab, any doubt?
No, sir.
Abdul Wahid? Okay, just write it down. I'm giving you some problem.
Done, sir.
Done, sir.
Wahid, have you done? Now there is some assumptions. The body is starting from rest. So initial velocity would be 0. Next, if a body finally stops, so final velocity would be equals to 0. And next, for uniform motion, acceleration would be equals to 0, or it means v is equals to u. Now on the basis of this, try to solve one problem. Body starting from rest, accelerates uniformly to cover 8 meters in 4 seconds. Find acceleration, velocity at 5 seconds, distance traveled in third second. Try to solve. I gave you some hint. Grab. Any doubt while solving? Just see in this question, we have body starting from rest. It means initial velocity would be 0. Accelerates uniformly to cover 8 meters in 4 seconds. So displacement is 8 meters and time is 4 seconds. So we have to calculate first acceleration. So use second equation of motion, you will get acceleration. On calculating acceleration, just use first equation and put the value of t to be 5 seconds, you will get velocity. And in last part, use fourth equation of motion and put n is equals to 3, you will get distance traveled in third second. Is it clear? Ma'am,
Yes, sir, I am done. I'm sending the answers.
okay. Shab, have you done? Abdul Wahid? Mamuna, just check your last result. I think you have sent me wrong answer. I'm gonna just check again. You have to put the value of n to be 3, u is 0,
Sir, for the last one, I'm using S is equals to UT plus half AT square formula.
No, you have to calculate distance traveled in third second. Here it is third, means point of time between two consecutive time gap.
Okay.
If there would be 3 seconds, then you have to use second equation of motion, because this term will define period from the starting point to that given time interval. Okay, Mamuna?
Okay, sir, I understood.
Shab, just send me your answer. Good, Mamuna. If you use second equation of motion, that is S is equals to ut plus half it squared, S is 8, u is 0, is we have to calculate and t is time taken, that is 4 seconds. So on squaring, it will become 16 divided by 2, which is 8. So on solving, you will get just 1 meter per second square as acceleration. Is it clear, Sharon? Now, for the second part, use first equation of motion. V is equals to u plus at. U is 0. Acceleration is 1. And time is just 5. So it will be 5 meter per second. Is it clear, Wahid? Similarly, in third part, we have to calculate distance traveled in third second. Third second is between any two consecutive time taken, or it will be between 2 to 3 seconds. So just use S nth is equals to U plus A over 2 times 2n minus 1. U is 0, A is 1 by 2, 2 times of n is 3, minus 1. So 2 into 3, 6, minus 1, 5 divided by 2, which is 2.5 meter. Abdul Wahid, you got the same answer? Good. I'm giving you one more problem related to this. In this part, we have body covering 9 meter in third second, 13 meter and fifth second. So just use fourth equation of motion, S and it, and put the values. You will get two different equations. On solving, you will get values for U and A. Is it clear, Mamuna?
Yes, sir.
Okay. Good, Mamona.
Yes, sir.
Your answer is correct. Wahid, have you done? S nth is equals to u plus over 2 times 2n minus 1. So S nth in this first part is 9 meter, u plus a over 2, and n is 3. So 2 into 3 is 6 minus 1, 5. So this will be your first equation. For the next part, S nth is 13, u plus a by 2, n is 5. So 2 into 5, 10, minus 1, 9. This is your first equation. This is your second equation. Now, if we subtract these two equations, minus, minus, minus. 9 minus 13 would be minus 4. U and U would cancel out. A by 2 taken as common. So it will be 5 minus 9, which is minus 4. So this minus 4 and this minus 4 would cancel out. So you will get A is equals to 2 meter per second square. Is it clear? Abdul Wahid? Now, if you put this equation or this value of A in first equation or second equation, 9 is equals to U plus A by 2. That is 2 divided by 2 into 5. 2 and 2 would cancel out. Move this 5 to the other side. You will get U is equals to 4 meter per second. Sure. Is it clear? Abdul Wahid, have you done? There is one more concept related to this, a reaction time. Suppose a driver is driving a car at some initial velocity u. In its path, suppose there is an individual at some distance in front of it. So you must have learned in biology about two different terms. First is stimulus and second is response. Mamuna, do you have any idea about these two terms?
Stimulus is nothing but it helps in sensing the surroundings,
Okay. And response?
Response is after sensing the surroundings, the response which we give, like that.
Okay, okay. Stimulus is nothing but any change in surrounding for which your body responded or would respond is called stimulus. So the total time elapsed or taken from getting stimulus to getting responded back is called reaction time. So let's say if a driver is moving at some velocity u and on observing any individual in front of him, total time taken by driver to get responded back or reaction time. So the total distance traveled from this point to this point, S is equals to ut plus half at square. Just 1 minute. So during this particular point, acceleration of car or body would be 0. So this part will become 0. So you will get S is equals to u times t only. So the total distance traveled during this particular interval is called as distance during reaction time. And in response of this particular individual, he must apply brake. So brakes are applied so that this car would start decelerating with some constant retardation. Let's say retardation caused is A. So the total distance traveled or covered by this car to move from this point to this point, and finally this car must stop at this particular instant. So its final velocity would be 0. So using third equation of motion, you will say v square u square plus 2as, as it is retarded motion, so you will use a to be negative. Object for the car is finally stopping, so this particular term would be 0. If you move this to the other side, you will get s is equals to u square over 2 times of v. This distance is called stopping distance. So in total, you have to solve for both these two parts. First, the distance traveled for the reaction time, and the next distance traveled to get finally stopped. If the total distance traveled, that is SR plus ST, if this term is greater than the actual distance between this part to this part, then this car will collide with this individual. Is it clear? Abdul Wahid, is it clear? Mamuna, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
I'm giving you one problem related to this. Just use this numerical value in the above equation and try to find both distances. First, we have velocity in kilometer per hour. So convert this in terms of meter per second. Yes, ma'am, Mona, do you have any doubt while solving?
No, sir, I'm solving it.
Abdul Wahid, any problem? In this equation, we have U, which is equals to 72 kilometer per hour. So just convert it in terms of meter per second by multiplying it by 5 by 18. So it will be 20 meter per second. Reaction time is 0.5 seconds. And retardation caused by break is 2 meter per second squared. So just use these equations in this part, and in this part, you'll get your answer.
Sir, I've sent the answer in the chat box.
I'm checking just 1 second.
Okay, sir.
If you put all the values for reaction time, total distance traveled during reaction time is 10 meters. And if you put all the values in the second part, that is for stopping distance, U is 20 into 20 and A is just 2. So it will be 100 meters. So total distance traveled during this entire journey is 10 meter plus 100 meter, and it will be equals to 110 meter. Okay, my Mona,
Yes, sir.
you have left this part, that is distance traveled and reaction time.
Yes, sir.
Just write it down. Mamuna, done?
Yes, sir.
Okay. Do you have any doubt till this?
No, sir.
Okay. So we have just finished this entire part till uniformly accelerated motion. Next class we will start free fall, that is motion with gravity, and then non-uniformly accelerated motion. Okay. So just
Okay,
revise this
sir.
whole concept and try to do more and more problems related to this. We'll meet in next class.
Okay, so thank you, sir.
Thank you.